Welcome to Cooper-Beeline Cable Ladder Training Lesson 3, Understanding the Difference Between Nema and IEC. In this training we will review the Nema standards and load tests required and compare them with the IEC standards and load testing. Before we get started, let's look at what we will be covering in this lesson. By the end of this lesson, you will be able to understand manufacturing standards for Nema, understand load classes, testing methods, and arrangements for Nema and IEC, follow installation guidelines for Nema, and explain Nema and IEC applications. You should take approximately 15 minutes to complete this lesson. Let's look at the Nema VE1 manufacturing standard. The Nema VE1 manufacturing standard was written by manufacturers for manufacturers. It specifies the requirements for metallic cable ladder systems designed for use in accordance with the rules of the Canadian Electrical Code and the National Electrical Code. The publication provides technical requirements concerning the construction, testing, and performance of metallic cable ladder systems. It defines typical nominal dimensions and tolerances, testing methods for load and electrical continuity, material definitions by the American Society for Testing and Materials, and labeling requirements. The standard that applies to fiberglass cable ladder is Nema FG1. The Nema VE1 is not available as a free or publicly available document. There is no IEC equivalent to Nema VE1 or Nema FG1. Nema load classes are a combination of a number and a letter. The letter defines the load in pounds per foot. The Nema letters used are A for 50 pounds per foot, B for 75 pounds per foot, and C for 100 pounds per foot. The number defines the span. Nema span is either 8 foot, 12 foot, 16 foot, or 20 foot. A 20C ladder would be strong enough to support 100 pounds per foot of cable weight on a 20-foot span of cable ladder. Note, Nema load class is the same as straight section strength. The Nema tests are set up and conducted in one specific way. To set up and conduct a Nema test, one cable ladder span is set up with supports at each end with no splices. Neither end of the cable ladder is clamped down. The cable ladder is loaded to physical failure. The length of the cable ladder is the span itself. For example, if you use a 20-foot cable ladder, the span would be 20 feet. Next, the tester continues to load the cable ladder until it physically fails to support the weight. If it meets or exceeds the Nema load requirement with a 1.5 safety factor for the specific span prior to failure, the cable ladder will pass Nema testing and then it will be given a specific Nema classification. Typically, third-party observers are not present for the Nema testing. Cooper-Beeline conducts Nema testing with 36 inches wide cable ladder. Cooper-Beeline's results are displayed in a table in the catalog for each series of cable ladder. Nema cable ladder testing consists of a simple beam where the load is applied until the ladder physically fails. Simple beam. Load applied. Load to failure. Unlike Nema, IEC does not list load classes. In the IEC specifications, the strength can be described in several ways. 1. Clear. The clearest way to describe the strength is when the project specification states the actual load and span for the cable ladder application of the project. Using a specific load span ensures the correct product is chosen for the application. For example, stating 140 kilograms per meter on a 6-meter span. 2. OK. Calling out a gauge or thickness of the cable ladder material. 3. Unclear. Making a generic comment of heavy duty or medium duty. The second and third description are sometimes listed on a specification, but are not as clear and are open to interpretation. In this situation, it would be best to contact the project specifier to gain additional information. Another aspect where IEC differs from Nema is that it has several test types and setups allowed. The test typically consists of multiple spliced sections of cable ladder to create a continuous span. More than one ladder length is tested and the results are shown in a graph. Third-party observers may be present for the IEC testing. The deflection is recorded, and deflection of 1/100th of the span length is considered failure. IEC load testing resembles a more typical installation than the Nema testing because of the spliced ladder system. There are 5 potential test types to select from IEC load testing. IEC has spliced plate limitations and also requires impact tests. The IEC load testing simulates a typical installation. IEC also specifies impact testing, which requires refrigerated samples of ladder to be struck with a weight at a distance to produce a given amount of energy. The impact testing is done by the manufacturer, and it is up to the manufacturer to decide the temperature and amount of energy at which to impact test the sample. These values are declared, and the testing results are based upon these. It can be difficult to compare published load ratings because the specifics of the testing method can vary and are not always published with the load rating. IEC consists of a continuous beam. The load is then applied until the deflection limit is reached, which is considered failure. Continuous beam. Load applied. Load to deflection limit. Along with providing standards for testing, Nema also provides installation guidelines. The Nema VE2 installation recommendations are for designers and contractors. They are guidelines that address installation and location of supports, field modifications, grounding and bonding, as well as handling and storage. The Nema VE2 document is free and publicly available for download on the Nema website. Here are the recommended guidelines for support locations on fittings that are outlined in the Nema VE2 document. For the most up-to-date information, refer to the Nema website. Note, these are guidelines and not requirements. In summary, Nema has only one setup test option, in which the ladder is loaded up to the point of physical failure. It also provides support recommendations. IEC has up to 5 different test setup options. The load test is deflection-based, and there are splice plate limitations, as well as impact testing done. You have come to the end of this lesson on understanding the difference between Nema and IEC. Let's review what we have covered in this lesson. You should now be able to understand manufacturing standards for Nema, understand load classes, testing methods, and arrangements for Nema and IEC, follow installation guidelines for Nema, and explain Nema and IEC applications.